Welcome to episode 242 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
I'm doing okay. Should we briefly talk about how your stream went last week?
Sure, why not?
So you mentioned, doing the Doom, converting it from C to C++. Yeah.
Really, the goal is really just to get it to compile with a C++
Right.
compiler. And I was streaming for 13 hours total. I took about 2 hours and 45 minutes in breaks during that. And then I came back, and at 11 p.m. my time, I just said, I'm done. I felt like Forrest Gump after he ran across the country 14 times. And he goes, I'm going home now. That's just, I was just done. So I shut it down, and then I came back to it on Monday morning, and I only had 20 minutes left of work to finish the linking to get going.
Wow. Were you able to play it after all that?
Yeah. Yep. It played. It was mostly just type conversions, just convincing the compiler that, sure, we treat that void pointer as a whatever,
Right.
Because C is like, whatever, do whatever you want to do. I don't care. They're all bits to me. C++ is not like that.
That's very cool. Okay. Well, at the top of every episode, I'd like to read a piece of feedback. This week, we got a message from Claire, and she's suggesting a guest. And actually, she suggested our guest from last week, Danielle Engert. So thank you for that suggestion, Claire. But this one is, she actually put a link to a different YouTube video. And I don't know if you watched this, Jason, but the video is from Tom Scott, and it's stopping a laser beam in midair. And I watched this. It's pretty cool. And basically, Tom Scott is the one doing all the talking, but the person who is controlling the laser wrote some software in C++ that's controlling the laser and making it so that with the way video cameras work, digital video cameras, he described the technique. I can't remember what it's called. But by turning the camera on its side and controlling the laser, like quickly starting and stopping it, you could make different effects happen, like having a laser beam appear to be stopped midair. And he does like the Kylo Ren force stopping a laser like he did in the Force Awakens movie, I think.
Yeah,
it's pretty cool.
I was just going to say, I don't see the point in the tricks. I can do that with my mind.
Well, it's pretty cool. And yeah, so there's a second video, which is just from the guy, Seb Lee, who wrote the software to control the laser. And she's suggesting we have him on the show since that library is all in C++. So maybe we'll reach out to him. Yeah, it could be cool to talk about lasers. Okay, joining us today is Jonathan Turner. Jonathan is a passionate open source advocate and programming language nerd. He joined Microsoft in 2012 to work on a secret project that would become Typescript. He stayed on at Microsoft for the next 3.5 years, helping grow Typescript and helping Microsoft shift to become more open source friendly. Later, he joined Mozilla, helping to grow projects like Rust, Servo, and WebAssembly. He also worked on LVM, Clang, and Apple, Chapel at Cray, and numerous side projects, including Chaiscript with Jason. In his free time, he's currently working on a new project called NuShell. Jonathan, welcome to the show.
Hey, awesome to be here.
Yeah, I think in full disclosure, this is where we mentioned that, yes, we are in fact related.
We are
share
related.
A common
It's
last
true.
name.
It's true. Yeah. I've known Jason literally my whole life.
No, that's not true. I've known
that's
you
true. That's
literally
true.
my
I'm
whole
6
life.
months older. Yeah. Okay. But we did spend quite a bit of time when we were young together.
Yes, lots of programming and gaming when we had the chances to.
So what was like the first thing the two of you guys did together growing up involving programming?
Cool. Well, I can remember two things. One of them, we had a game that we were working on that, so at flashback, put the waves in, right? Flashback, back then, Ultima was like the hottest role-playing game.
Uh-huh.
And everyone that I knew in high school was trying to make an Ultima clone. So, of course, I was trying to make an Ultima clone as a budding programmer and talked Jason into helping me with it. We actually dug up a compiled copy of this. I don't know if we want to put it online though. But
I do have it. Yeah, we both have
yeah,
a copy. Yeah.
I think that is like one of the first projects that we collaborated on. But we've
I think it
written,
must be.
yeah, we wrote an operating system in high school together that we put in the science fair and then got like first place, which is pretty awesome.
That's pretty cool.
It's very simple, but yeah, that was fun.
Yeah, and then flash forward, we did Chaiscript in 2008, 9. I don't know. Jason, help me out.
I think 9 might have been when we tagged. Yeah, I think 2009 was the first commits. Yeah, which were on Google Code
Yeah,
or whatever at the time. One of the canceled Google projects.
Right. Very cool. Okay, well, Jonathan, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about some of the other programming languages we just mentioned that you've worked on, okay?
Sure.
Okay, so this first one is Format 6.2 was released. What are some of the highlights here, Jason? And I got to ask, like, what is Format still have enough in it that it's worth using compared to what's going to be in C++20?
I think once your vendor supports it in C++20, you should probably just use what's officially there. But I don't know. It's going to depend a lot on quality of implementation or whether or not they grab his implementation and such. But the top change here, that you get better compile time errors instead of 17 pages of template errors. If you try to output something that doesn't already have a formatter that exists for it, is huge.
Yeah, definitely.
Yep. When I saw this, I pinged Jason. I said, "You're trying to set me up, right?" He's like, "What do you mean?" So there's a very similar thing in Rust called FMT or format, and it looks exactly the same. And but we learned very quickly that they're both inspired from Python, which is kind of a fun fact.
And that one is also in the std namespace, it looked like, in Rust or something.
Yeah, it's part of the standard library in Rust.
So they'll end up like looking, very similar, I guess.
That's good. Cross-pollination is a good thing.
Yeah.
So if you didn't catch that, and I know you don't necessarily follow every bit of the C++ standard, is this has been approved for C++20, but not the full suite of utilities. Mostly the format to a string portion of it has been approved, but not any of its like direct printf replacement kind of options.
Okay, next article we have is SourceTrail 2020.1 new version, and the new thing, main new thing here is keyboard-based navigation. So if you are not a heavy mouse user, if you try to do most things with the keyboard, you can now navigate around the app, which I'm sure some of our listeners will find handy.
I think to me the more significant thing is that it's the first release since the project became open source.
Very true. Very true. And we should mention again that they are looking for patrons to help support the project now that it's open source. They're certainly doing better than they were on the Patreon since we first mentioned that maybe a month or two ago, whenever that was.
Yeah, they only had like $10 in support then.
Yeah. So they're still not at their goal though. They're like halfway. They're at 230 of $550 is their goal. So definitely try out SourceTrail, and if you like it, you should definitely consider becoming a patron.
They also have a few dozen committers now.
Oh, nice. That's
I'm
very
kind
good.
of curious if John has any comment on this. Not SourceTrail, but since you've been involved in a lot of projects or tried to push open sourcing of projects and that kind of thing, just, I don't know, any general thoughts from what you've seen here?
I don't know in particular about SourceTrail, but something I was just thinking about is kind of flash forward a bit to when we're talking about TypeScript. When TypeScript first was open source, it was on the Codeplex, which was Microsoft's proprietary open source thing. It felt like every company had one of those at one point.
I think Codeplex actually still exists, though, doesn't
I
it?
think it does.
Yeah.
I was told at one point it was like a machine under someone's desk. I don't think that's true, but that's kind of what it sounded like. And when we moved TypeScript off of Codeplex onto GitHub, I think overnight I had 10 times the number of, viewers of the project, and then it just kind of skyrocketed from there. So just getting into Vue and getting into Vue in a really open source way, it makes a humongous difference.
Yeah. Okay, and then this last thing we have is a post from Arthur ODwyer's blog, and it's when is pointer X also reference X? And I thought this was a pretty good post, kind of explaining some of the differences and his way of remembering the differences. Although I did want to get your take on his one suggestion here, Jason, where he says to teach pointers first.
No, I don't teach pointers first, but I also
Yeah.
try really hard to not teach intro to programming classes. I know that that's not
true.
my forte. So I've been surprised a couple of times when I was teaching introductory classes that I didn't expect to be introductory classes. And, at the first break, I go, okay, I need to rearrange what material I'm teaching now. It's not a surprise that I prefer to have. Yeah. I think the sad thing for me, though, with this article is I saw the headline and I said, with function pointers, and then I said, I've spent too much time with this language.
Yeah. Anything else you wanted to comment on with this one?
It's fun. Yeah, there's some good lightning talks that are kind of similar about some of these things you can do with function pointers too, though I can't remember the titles now.
Okay. All right. Well, John, so we talked a little bit about in your bio just all the different languages you've worked on. Do you want to tell us maybe what you're working on currently to get started?
Sure. My current project, and if you get me talking about it, it will be the whole podcast. So make sure we're time limited. Yeah, I'm really passionate about this project. It doesn't sound like it would be something that would hook you as deeply as it's hooked me. It's a project called NuShell. Well, that's the current name. We may come up with a better name, but let's go with NuShell for now. And NuShell is a... okay, what is the elevator pitch? So we've got PowerShell, which is like an object-oriented way of thinking about shell. So it's not just text in, text out, like standard in, standard out is only text. You actually have this ability to work in objects. Flash forward, I was talking to some friends last year, and we were thinking about what happens if you have structured data pass through this pipeline, not objects, not state, not mutability, but actual like structure that you can destructure it on the other side. You can work with it as if it never lost the structure that was in the original file. And so that is basically was like the initial idea. And then from there, it's kind of grown out to being how can we think about programming in a bit of a broader way and something that's a little bit more beginner friendly, but has all the capability of being a shell, has all the capability of working with data. So yeah, I'm sure we can kind of drill into that more, but that is something that I'm really loving working on.
And that's open source.
That's open source. Yeah. You can find that on GitHub, NuShell/NuShell or something.
Okay. Well, maybe instead of going too deep on that right now, we should start with what first got you interested in programming languages, because you worked on so many.
Yeah. So this was kind of a surprise to me too. So back in 2005, 2006, I was working with a mutual friend of me and Jason that we went to college with, a guy named Minow. And we had a contract we were working on together, and my coding in that contract, I will just fess in this podcast, it was not the best. I kind of cut a few corners. And it kind of came back and bit me. And I realized like there was so much more about programming that I wanted to learn so that I was always ready. Like I always could go deep and have like really strong solutions to problems. And that's really was the impetus to study programming languages and to study how do I do how do I work in these languages in a way that is actually really smart? Jason, to his credit, was by that point, I think, was really starting to dig deep into C++ and was starting to pick up like how do you do really strong C++. So he was a good a tailwind, I would say, to push me deeper into this pursuit of how do you think about programming? How do you do really good programming so that the code that you read is very readable, it's very crisp and clean? And then I started thinking about, all right, if you could remove all constraints as an engineer and just build a good programming language, well, of course, that's a bit, the audacity of that is pretty obvious, right? But it's a good way to think about your problem in a different way. So I started making these little programming languages. I made one that looked like English called Pineapple, the pseudo-natural programming language or something. It was terrible, absolutely terrible, but it was a good start to have something where you're working on a parser and then it does a thing and then you're like, oh my gosh, look, it does a thing, and then you write a little bit more and then it falls over and like, okay, I need to think a little bit deeper about how this is built. So yeah, I worked on Pineapple. I worked on a couple other languages. I think it was like a year or two later, Jason had this idea for working on an engine. It's like we can make, so I think at the time you're working on, what was that, that language binding layer into C++?
Dispatch kit?
Maybe.
No. Oh, Swig. Working with Swig.
Swig.
Yeah.
So
Oh
he's
yeah,
working
and I
with-
hated that.
That's right. So he's working with Swig. Maybe I'll have Jason tell that part. But basically, he saw Swig and that it could bind to basically any language in, but what would it be like to have a language that sat naturally inside of C++, that could use all the types for C++, use the way the dispatch works and everything. And so he started working on an engine, and at that point, I was 2 years in to designing programming languages. I was like, hey, I'll write the scripting side of that for you. He's like, done, go for it, write the parser. So that was the first early versions of Chaiscript were born from those early experiments.
Yeah, without someone who knew how to write a parser, that never would have happened. It would have just been an interesting library.
Yeah, very cool. So how did you go from kind of building your own language, open source project to going to Microsoft to work on TypeScript?
Yeah, so I kept doing these programming languages. I worked on Chaiscript with Jason. And at that point, I also started working on one called Minow, which...
I was trying to remember the name of it just now.
Yeah.
I'm like, it was a fish. What the heck was it? For anyone watching the video, that was the look in my face here. I was trying to remember what the heck that was.
Yeah, so this is a predecessor to Go, but a similar idea that everything was an active object or an actor. And you could send messages back and forth to these things. And they all sat on lightweight threads.
I was going to say, you should probably describe what active object is.
Oh, yeah. Let me do that. So let me back up. So an active object or an actor is so you've got a normal object, and the only way to interact with it is to call a method directly on it, right? So you call the method directly. That means you've got a pointer to it or a reference, and then you can get to it. What an active object would be imagine an object that's sitting on its own thread somewhere, and the way that you communicate with it, you've got a channel that you can send a message to it. So it's sitting there on its own thread waiting for messages on that channel. It gets a message. It does something. It probably like mutates itself in some way. And then the only way it interacts back with you is through that channel or through a separate channel. So instead of everything being asynchronous by default, now all of a sudden everything's asynchronous by default. You have kind of a mesh of these messages being sent back and forth between these actors. So the model is interesting in that, you can model, as we found with Go, you can model like services that way. As these messages come in, you can kind of field them and spawn off some workers, and they can do something interesting. So yeah, that was one I worked on for a while. I got it really fast for one benchmark, and I was really proud of myself for that one benchmark of speed.
You drove yourself nuts with lockless queues at that point, right?
Yes, I did. Yeah, if anyone is listening and knows what the ABA problem is, that's what I hit, which is like, I don't know if we really want to dig into it right now, but maybe. Okay, here's the TLDR of ABA problems. So you have like a message come in, let's say that's A, and then you delete that, and then that goes back into a memory pool that you can reclaim later.
Okay.
And then so something else comes in as B, but before your lockless compare and swap happens, you've deleted that and replaced it with the first one again. So your compare and swap succeeds when it should not have, because you're on recycled memory. So that is a gotcha that you have to watch out for in lock-free data structures. And I had no idea what that was until grad school, and I was like, oh, that's why it's hard. I got it.
Yeah, Tony Van Eerd has been doing a series of talks at C++ now called a lock-free Q part whatever, one of N. And he does another one every year at C++ now. I don't know, he's on like part 4 or 5 of N. And the conclusion is always, don't do this.
Don't do it. Yeah, don't do it. I switched the lock-free thing out. I don't know if I told you that, Jason. Before I was applying to grad school, I did switch it to a locked version, and it was just as fast, and it was, correct, which is a good thing to have, fast and correct. So I worked on Minow, and I loved it so much that I actually quit my job so I could work on it full time. And after about a year and a half of that, I said, I should go to grad school. Like this passion will not leave me alone. And if I go to grad school, I at least have a piece of paper to show for it. So that's what happened. So I went to grad school in Boulder, Colorado. So I was living right beside Jason, and which was awesome. We got to hang out a lot and work on projects. And I did that for a few years and worked at Apple on LLVM, got to work with Chris Latner, which is amazing, and Doug Greger, who's also totally amazing. And we worked on C++, kind of a module system for C++. What they didn't tell me when I interviewed at Apple was that in this interview, they're like, what would you say you would do to make your perfect programming language? And I described this thing that had a trait system or like concepts back then. So it has a concept system. It has better modularity, so the modules are nice and clean. And they had to have been laughing on the other side of that phone when they were interviewing me, because this was before Swift now. Mm-hmm. They were working on it in secret. And I just described what Swift was to them over the phone. So yeah, I got the internship and then went and worked with them, which was an amazing experience. They're just brilliant, off the charts.
I think related to that, and maybe worth the aside, is, do you want to talk about what your professor that you were working under was doing?
Yeah. So my professor then was Jeremy Seek. He was my PhD advisor, though I did not get the PhD. No spoilers, but yeah, did not get the PhD. But he had been working on a few different projects. One of them was concepts in C++. So he and Doug Greger worked together on the original concepts that did not make it in. But I think kind of laid some of the early thinking and groundwork that would, be the revised, clean, simplified version later on. Right. So they worked on that really hard. Jeremy, was one of his main things in grad school was around concepts and how do you deal with the complexity, the subtle complexity. It's off the charts. I remember reading some of his papers and just like, wow, this is amazing. So yeah, I worked with Jeremy. Jeremy's other project, which kind of leads us into Microsoft, was he was looking into gradual typing systems. And at the time, it was like gradual typing Python. So, normally Python is dynamically typed. It has no types in the code. And what happens if you actually sprinkle some type information where, you want a little bit of checks, but not a whole bunch of checks. You can just sprinkle a little bit in. So he was experimenting with that. And lo and behold, Microsoft also was experimenting with that. So the second internship I got, or the third in grad school after Apple, was Microsoft. And that's when I started working on the TypeScript project.
So I guess we just skipped right over Chapel at that point.
Yeah, sorry.
That's fine. I just realized I don't really know anything at all about that language.
It's really, really cool in that it's meant to be a systems language, but it's also very parallel by default. So it has I guess maybe its claim to fame, instead of having an index. So, all right, here you go. So you index into a vector in C++. It's just a number. Mm-hmm. And you calculate right to that place in memory. Okay, that's cool, but what if your memory space is stretched across many, many, many machines? Do you still use just a number? Well, the trick that they figured out is if you have just a way to calculate the index from like a simple function, you could kind of project that code onto different machines' data sets by just like rewriting the index that it's looking in. So, still imagine that your memory addresses are contiguous, but the addresses run across many, many, many machines. Now you can just lay the data across all these machines, and the indexer would say, they have this this idea called like a distribution. So the distribution would lay across all these machines, and the way that you would index into them, it would kind of be like, I can't remember the exact algebra, but it would be like machine number plus offset in that machine would be the actual index. Right. So you could just have a function that would create these for you. And now you've got indices that will jump you into whole blocks of data across these many machines. So I may not have done the best explanation of that because it's a bit rusty, but maybe you can get a sense for working at really large scale distributed systems, and the code that you could write across this just treats the whole thing like one machine. All right, so you've got X number of processors and X number of X amount of memory, and all of that is handled by the compiler.
This makes me think. I C++ Twitter, I'll have every now and then see comments from people that are like, oh, do we really care that the size of a vector is 64-bit? No one actually has more than 4 billion objects in a vector, right? Yes, people do put more than 4 billion objects in a vector.
Exactly. Go model the weather.
Right.
Yep. So that was kind of cool. Chapel, most of the stuff that I worked on at Chapel, I did implement concepts in Chapel. I helped them with the module system, and I had an internship at Cray, and there I worked on like lambdas and passing around functions to first class functions. Passing functions to whatever. Whatever it is. Passing functions to first class functions. Is that right?
Passing class functions. You could do that. Sure, why not?
Sure. But being able to pass functions, and whatever, so that it could be arbitrary.
Right. We kind of glossed over your modules that you mentioned when you were interning at Apple. Do you know if that ended up becoming Klang's implementation of modules?
I was like racking my brain to remember the design that we had at Apple. I remember some of the stuff they were trying to tackle was around, so C++ has carried along with it C's macro system.
Right.
And the macros have this really nasty name polluting side effect. It's not pretty. And so if you think about modules as having to be separate compilation units, having the macro system muck with that really breaks that. So we had some rules that we built around like macros that were allowed to exit, and then as they exited, what they were allowed to do to the namespace as they exited. But beyond that, I can't remember the details.
It all sounds like stuff that they continued to argue with for the next, what was that, probably 8-9 years ago you were working there?
Yeah, 2011.
Yeah, okay. That they've continued to argue about for the next 8 years until we got a standard for C++.
It's nasty. Yeah, totally. My I designed this other thing at Apple too that we'll talk about Rust here shortly, and it was kind of a stroke of luck that I ended up designing something very similar. So I had thought, when you compile C++, you compile, you can get some object file, but then you have to lug around this header at the same time. And the header allows you to stamp out your templates and actually get specialized functions for, good optimization. I was like, you need to be able to bundle this together. Maybe we call that whole thing a module. And sure enough, that's how Rust does it, so that you can still specialize and get all your generic functions get specialized on the type and get, highly performant. But in order to do that, they have to lug around the metadata and the kind of the pre-processed source code.
Yeah, that's our guest last week basically described C++ modules as containing a form of precompiled header for that kind of use case as well.
Yeah.
So we're getting there.
Yeah, yeah. Once you have it, it's like, it's great. Like, we love it in Rust.
I guess before we talk too much more about Rust, could you maybe go back to Microsoft and TypeScript a bit? Because I think you kind of hinted at, sprinkling types onto a language. I'm not sure how many of our listeners are familiar with TypeScript, though.
Sure. So I guess maybe the elevator pitch for TypeScript is, imagine you've got JavaScript. And this is great for making, what they say, like the monkey dance on the screen. You put a couple lines together, it animates, everyone's happy, right? And that was kind of JavaScript's original use case. But, you flash, 20 years into the future, and now you're having to write full applications.
Real programs.
And the only way to write it, you've got like tens of thousands of lines, hundreds of thousands of lines of JavaScript. Which, that is a recipe for disaster if you don't have some kind of type system, some kind of static analysis to help you out. So that's really where TypeScript, kind of came into being. We are working with, so this is the developer division at Microsoft, was working with people like Office or making these gigantic web apps. And they needed something that they could use that was more performant and whatever. And the most performant thing that you could use is just JavaScript. So that kind of kicked off this idea of, you take JavaScript and then lay on top of it an optional layer of types. And these types just peel away, and you don't get like really gross JavaScript as a result. You should get JavaScript that's like you would write by hand. So that's really where it kind of, this idea of types just for the sake of tooling and for kind of static analysis, not for necessarily optimization, not for, some of the other stuff that you would use types for in a compiler. Basically only just the tooling side. So we did, they had an early implementation of it before I started, so it wasn't even public. I kind of came in and helped them with some of the last, bits and bobs that they needed to fix in the design, and then helped them take it public. And that was, it's an experience that, I think I will always remember, trying to talk to JavaScript developers about, hey, here's this typed thing, and they just kind of stare at you blankly, like, why would you do that? Right. So then I open my editor, and then I start getting auto completion, and they're like, hold on, what was that? Go back. What was that? And then I get squiggles when, I mistype something in this JavaScript standard library. You get a red squiggle, and it's like, because I mistyped it or I passed it the wrong type. And so little by little, we started getting a small following. And at the time, we had no idea if the project really had legs. We knew we had a couple of teams interested, but that was it. So we kind of took it public. And then I spent the next 3.5 years, kind of being a player on the team and then being the lead of the kind of the design team for TypeScript and helping them like really flesh it out for all the use cases. So one of the big things in the JavaScript ecosystem are these JavaScript frameworks. So like Angular or Ember or React. You may have heard of some of these in your work. So these are like really complex machines, right? And I wanted to see if we could get some of them using TypeScript, because if you did, now anyone using Angular or React would have a bunch of type information. They don't have to use it, but it's optionally there that they could pull it in, then their editor could light up and you could get all these auto-completion and errors and whatnot. So that was one of the last things that I did on the TypeScript team, was I got the Angular project moved on to TypeScript and then started the Ember project moving as well. And so, that was really awesome, because after I left, I kind of said, all right, here, replacement, good job. If you have any questions, you can always ask me. And then I just went away and then just got to watch TypeScript just take off, which was an amazing experience. I was definitely waving my pom-poms from the sideline. So.
I was going to say, it definitely has taken off over the last few years. Like, isn't Google using TypeScript now?
I think anyone who's doing a serious JavaScript project does, honestly. I'm curious what that first editor was that you were showing it off in. Was that Visual Studio, VS Code? Do you remember?
I think the very, very first one was Visual Studio.
Okay.
Because VS Code hadn't even been created yet.
I couldn't remember.
Yeah. It was a project called Monaco, which was an online editor that used the same logic. Incidentally, also written TypeScript. They were written in the early version and had to keep rewriting because we kept breaking them. So props to them for continuing with it, because it turned out really good for them later on. So so when VS Code actually came out, then we kind of added support. And then that's basically, these days, that's what you would use, would be VS Code.
I know Matt still listens to the podcast, and he might correct me here, but I'm pretty sure that Compiler Explorer's code editor is Monaco. That sounds
cool.
right. I think that's right.
Yeah, that's awesome.
You can right-click and get familiar-looking menus.
Very cool. Okay, should we talk about Rust and your involvement in that?
Sure. All right. So after 3.5 years of working on TypeScript, I kind of hit a limit where I'm like, I'm not going to work on programming languages anymore. I'm done.
And to Rust.
Yeah. So I took a vacation. I could clear the cobwebs out. I live in New Zealand now, and part of the reason is because I took a vacation and came through New Zealand on that vacation.
So you're supposed to get a visa. You're not allowed to just stay, right?
Just stay. I'm never leaving. I'm going to be a hobbit too. So
just to be clear, he is living there legally. I'm just giving him a hard time.
Right. Now immigration is going to come looking for me, Jason.
Right.
So I took this vacation, and at the same time, so I mentioned Ember earlier. Someone that I met, while I was working on TypeScript, I was also working on the JavaScript design committee called ECMAScript. So this is like the standard JavaScript body. And then once that's published, the browsers take it and turn it into JavaScript.
Okay.
One of the people I met on there is this guy named Yehuda Katz. He worked on like Rails, Ruby on Rails 3. He's like in that area, he's like a really well-known developer. But I had only just met him through the committee, and he and I kind of stayed friends. So we just kind of hit it off. And after I left TypeScript, he kept banging on about this Rust project. Now, I had seen it before, and it looked, I'll admit, it did not look very good. It's like, it has some good ideas, y'all, but I see a bunch of ampersands. I see a bunch of sigils. This is not pretty. I'll stick with C++ or whatever if I'm doing systems level stuff. And he just like kept saying, you should try it, you should try it, you should try it. So I finally said, okay, fine. So I did 2 projects with Rust. I worked on a Chaiscript-like thing called Ray, RHAI. So I just take
wondering
this.
how you pronounced it.
Yeah, right. If you take the C and turn it into an R because it's not C++, Rust, right? So I did that to try to understand how parsing would work and the type system works in Rust. And then the other thing I did, which Jason loves to chat about sometimes, is I like to write Nintendo emulators. That's how I learned programming languages.
Hey, now,
So,
to be fair, this is awesome. Go ahead. Since you brought it up, go ahead and list all the languages that you have written an NES emulator in.
C, C++, C#, Java, maybe Java, JavaScript, TypeScript, Rust.
Wow. Okay. It's a way to learn.
I mean, if you use the same docs, you start figuring out the patterns, and then you just have to figure out the language after that. But the nice thing about having a project like an emulator is that for me, there's a lot of nostalgia. The Nintendo was my first console that I really loved as a kid. So you have a lot of joy just getting, oh, Super Mario works. Holy crap, that's amazing. Like that joy doesn't go away the 10th time that it happens. You're still like, yes, Super Mario.
And that's the easiest one to get started with, right?
No,
Super Mario.
it's actually really hard.
Oh, I thought Super Mario Brothers 1 was, okay, never mind.
No. Yeah, it's not the one you should start with. If you're listening to this and want to do a Nintendo emulator, pick a different game. Pick a different one to start with.
You have to give a recommendation now. You can't just say that.
Yeah, I know. I'll think of one. We'll put it in the show notes or something. But the reason, I'll just tell you why a Super Mario is a little bit hard. You have to, oh gosh, this is not a Nintendo emulator podcast.
It's fine. Go for it.
It's fine. Yeah, it's fine.
So when you're looking at the play screen, there's that little coin at the top where it says how many coins you have.
Uh-huh.
Underneath that coin, there's a little half sprite. And that is how it knows how to switch from the score display to the play display. And so all your timing has to be correct. And then it trips across the bottom of this coin. And that has to be correct. And then the play screen will draw correctly. So you have to have a fair amount of the Nintendo emulating well before that works. Yeah, definitely try not to do that one first. But I still, I like the challenge. So yeah, did the Nintendo emulator. I did this other Ray project. And then just fortuitously, I don't remember if it was Yehuda or if I was following the Rust Twitter account. They said, oh, we're looking for a new developer on the Rust team at Mozilla. If you're interested, come hit us up. And I said, well, I've got all this. I worked at Microsoft on TypeScript. I'm doing all this Rust stuff right now. Maybe, I don't know, maybe we can work something out. And so that led to a bunch of interviews, and I ended up at Mozilla working on the Rust project. And that was awesome. I mean, it's just a passionate group of folks. I had met some of them a couple of years earlier when I was at Microsoft. I put on this thing called lang.next, lang.next.
Okay.
And it's like how many language developers can we get in one room? Like we had Breanna there. We had what's the guy that did the C++ template metaprogramming book?
Andre Alexandrescu?
We had Alexandrescu talking about D. We had a bunch of people, which was amazing group to have. Incidentally, I'll tell this one quick Breanna story. So we had him at the speaker dinner, and I was sitting beside Nico, who was the lead of the Rust compiler team, and like Breanna's like sitting across the table, and we're just like chatting him up. And once he realizes that we actually like C++. We're not just here to like dog on C++. We started having this really awesome conversation about what it was like to design C++ over the years. And so much so, he said this little nugget that to him was probably just this throwaway set of sentences. But he said, you realize that when you first design something, at first, people resist it because they think it's too subtle and they make you make a bunch of syntax just to make it obvious what's happening. And then, they start acclimating to it. So there's kind of like a middle period where they acclimate. And then by the end, they're complaining that there's so much ceremony and syntax. Why wasn't it simpler? And so this kind of became Strustrup's rule. And this is something that in the Rust design team, they still use this to this day. This idea that, you have to be careful how much ceremony you're putting on new designs because people have to acclimate and you have to give people time to acclimate to a design. So yeah, that was cool. I had met some of the Rust folks, but then actually getting to sit and work with them day in, day out. I mean, it's just a bright team of like really good-hearted people, it was an awesome experience. I kind of helped them at that point. I don't want to take too much credit, but it was at that time it was a research language becoming a full-blown industrial language, and so I kind of came in with my 2 cents and like helped give them a push in that direction. One of the things that I worked on was the usability of the language. So specifically around the first thing I did was error messages. We worked on a kind of a cleaner way to print out an error so that you can actually see your code, not a lot of error messages, just most of your code. And then we would just underline under like hot spots, interesting areas in your code that, okay, this is where the error is. And you give a little label beside that. Okay, this is why it happened. And then also some secondary. Okay, here's a secondary line and all right, here's a definition that came from here. So you look at the code and in like 2 seconds, you see the big red squiggle, the message, the line number, and also maybe some secondary information. And when people tried this out, it was surprisingly positive, which to me, for such a big change, was really great feedback. It's like, yes, yeah. We're going the right direction. And then, now it's kind of a thing that Rust is known for, is having an error message that just jumps you straight into the code that you wrote in the order that you wrote it, and like labeling so that you can jump right back to your code and know how to fix it as quickly as can be expected in a compiler. It's not 0 seconds, but there's definitely a speed up from where it was before, which is really great.
My memory of these events is that just a few months after that was when the Clang team was like, hey, look, we have better error messages too. And GCC also now, and we see the whole C++ world anyhow is starting to get to the kinds of errors that you're talking about. We were discussing even GCC 10 last week, right, Rob? Yeah. With like, they're putting in hyperlinks. If your terminal supports it, hyperlinks, so you can click on the error and it'll take you to the documentation.
Awesome. I love it. Yeah, I knew it was kind of like one step in the right direction, and then once people took that, they would just kind of keep building and evolving it. So I love it. I think it's great. The other thing that I worked on as part of this usability effort was to build their first language server. So people may not know that when you're working in IDE, you have basically a live compiler in the background all the time. That's how it can do the error messages, the squiggles. That's how it can do autocomplete and whatnot. And the way to do this is actually completely different than you would write a normal compiler. So in a normal compiler, you might hit build and now you've got to wait seconds, minutes until it's complete, right? You're not going to wait seconds. If I hit dot, I want you to give me the answer. Like, I'm not going to wait 30 seconds to get the answer when I'm in an editing situation. So there's a lot of techniques that Microsoft and others built up over the years to create the data structures in memory that you can update live and would hold pretty much everything in the memory state, in the state of the program. But then as you're editing, would just update the little bits and pieces that need to be updated, recompute that, and then give you the type information or the autocomplete. So I worked on stuff like that for Rust. It was kind of it wasn't the greatest piece of engineering, I will admit. I just got it enough to work, and then you could get completions, you could get error messages. But the hope was to say, here's error messages, here's IDE experiences, we can have nice things. I think that set a nice precedence that now, once you kind of set that higher bar, the command line tools or the error messages or whatever it is, if they don't meet a bar, it feels like, oh, that's not quite the Rust way. It should be a little bit nicer. And that's a great thing to kind of instill into a small group of people, and then from there it grows out into more of the community. So then after I worked on Rust for, I guess, a couple of years at Mozilla, and I saw Servo, which was it's like an experimental web engine written in Rust. And they had started porting out part of Servo and putting it into Firefox. So Firefox users may remember Firefox Quantum, and that is the first time that they actually took out something from Servo and put it into Firefox. It's the first reasonable sized chunk of Rust in the Firefox code base, which, as I recall, caused no end of consternation to Linux distros. So a little bit of apology to those Linux distro people that had to weather adding a whole Rust compiler and toolchain to your distros just to compile Firefox. So yeah, we worked on that. I worked on the Servo team for a while. And I guess the last thing I worked on was I put together the WebAssembly team at, I wouldn't say like I put it together. I just kind of, the loose coupling of WebAssembly engineers, I kind of gave them a weekly meeting that they could talk to each other, like from different parts of the organization. And that helped kind of shape the early days for WebAssembly. It had just become ratified. And then this gave us a chance to talk about how do we tool WebAssembly? Like how do we get maps into the original source code? How did we build a set of additional tooling? So I did that. I worked on that for a while, and that was kind of the end of my Mozilla tenure. But feels like a good chunk of work.
Yeah, I think you just outlined 15 years of being involved in programming languages for the most part.
Yeah.
Does that make you feel old?
Well, but now that you mention it.
Do you have any advice for anyone who's thinking, hey, I've been wanting to make my own toy programming language to do this thing?
Just do it. I mean, I think your ambitions will outrun your skill, and that's how you should start. And then try it out. And then learn how to do a parser, learn how to do a type checker. My skill level was at like a certain line. And when I was working in grad school, Jeremy, my advisor, Jeremy Seek, said, you need to read this book and understand it. And it was a book called Types and Programming Languages. Please do not start with this. I feel like the warning podcast. Do not start with Super Mario. Do not read Types and Programming Languages as your first book. Read it as like your second or third one. It's incredible because it will like really level you up in the way that you think about how a programming language is put together. So like, what is a function? What is a structure? What is a record? And then you start thinking about what is a trait or a concept. And he just kind of keeps raising and raising the level of abstraction. And while he does this, between each chapter, there is a little programming language that is basically like the simplest programming language you can think of, plus this new feature. And so you can see it in isolation. So to really learn my way up into the skills that I needed in grad school, I went through that book, and at every one of those chapters with the mini language, I just went and implemented that and then played with it. And then I went to the next chapter and then implemented that. And I just went through the whole book and implemented all the languages. As you begin to get faster and faster and faster, by the end, now you've written a parser, you've written all type checking for all kinds of forms. And it's a great way to work up, to be able to do a full-blown programming language if that's what you want to do.
So what's your next programming language?
After NuShell? Let's just do NuShell first. That'll be...
Okay,
sorry.
I was just going to say, are you done with programming languages now and focusing on NuShell? You want to talk more about that?
Sure. I think I kind of gave a brief introduction at the beginning. Mm-hmm. But one of the things that I like about NuShell that I think is apropos for the podcast is that you can extend NuShell with plugins. And the plugins, all they do is talk with JSON, JSON, not JASON. Yeah.
It happens all
JSON.
the time. It's fine. Yeah.
They just use JSON to talk back and forth with the NuShell kernel. And so you can write a plugin in any language. In fact, Jason wrote one in C++.
I did to prove it was possible, yeah.
Yeah. Is it possible, Jason?
It is possible, in fact. It didn't take that much effort. I think the hardest part was picking a JSON parser that I wanted to use for C++, basically.
Yeah. So I think that's one of the nice things about it is not only does it have this structured way that it views data, but you can participate in it and you can kind of participate in your own language. And you just use the API, the JSON-based API. All you have to do is read in and standard out. And that's the whole protocol, basically. Yeah. I just did a bunch of work last weekend on it. And I'm looking forward to doing it again. This is one of those projects that, I don't mind working nights and weekends because it actually feels like, it kind of fills me up, Scratches that design itch and scratches the right hobby itch.
What's a good example of the type of thing you can do with NuShell that might not be possible with either regular command line or PowerShell?
Sure. So you can do this a little bit in PowerShell, but maybe the canonical example for new is you type ls and you hit enter, and what you get back is a table. And it's not just, a pretty ASCII drawn table. It's actually a structured set of rows and columns. So you can query this. You can pull out a single row or you can pull out columns. You could say ls pipe where size greater than 10 kilobytes. And it knows how to understand what each of those mean. And then as ls outputs each row, the where command, the second one in the pipeline, then does the actual filtering. Mm-hmm. So it's much more composable. And because all of the commands talk in the same data description language, if you want to call it that way, the data type language, they all connect together. So if you understand how to filter the ls table, the same thing works. If I type ps and get a bunch of processes, I can filter that table and work with that as well. So that's kind of, from 10,000 foot view, that everything, all the commands in new are this structured format, allows you to compose really long lines of, useful things that would be kind of hard to do if you didn't know your bash really well. You would have to remember all the command line arguments, and then you would have to remember how to compose all these together. But because new is functional and kind of is compositional style, you can just write the pipeline up to the point that you can figure out up to that. And then it outputs the table as it stands. Oh, that looks good. But you know what I should do is reverse that. And then you say pipe reverse. And then it reverses it. And then you just kind of, you just experiment and it's interactive.
I know exactly one person who would go, well, I could just do that in awk in one line.
There's always that person.
There's always that person. Yes.
This is an aside, and this is not to knock C++ at all. But there's always that one C++ person that can say, hey, I can do that in C++. Why am I listening to you? I had one of those in one of my chapel talks. I'm like, I could just do crazy template metaprogramming. You can. It's true. If you know how to do it, go for it.
That is, I guess we're getting about to the end of our time here, but you have a plethora of talks online as well yourself if people want to go find these.
Yeah, if you're interested in TypeScript, you can search for TypeScript, Jonathan Turner. The Rust stuff, I was telling Rob before we got on that I used to do a Rust podcast called the Rusty Spike. If you want to hear some old Rust news, there's that out there. And I have the blog that I write every once in a while. I write a blog post. And so there's blogs on NuShell and Rust of various topics in Rust if you're at all interested in that.
And I think if someone were to get particularly bored, I think they can still dig up Minow.
They can. Yeah, I don't
I'm
know
pretty
if
sure they
if you
can.
can find it. Good for you. Yeah, it's out there somewhere.
Okay. Well, it's been great having you on the show today, John. I'm sure we could go on for a lot longer, but it's been great talking to you.
Oh, it's been awesome.
Thanks for coming on.